The third case for demand being inelastic, this could be a case of certain commodities that have got no substitutes. Okay, for instance, the case of insulin. Even if the price of insulin was to be increased today, people will still, buy because they have to survive. If they don't inject themselves, then they're going to die, right? So for such commodities, demand is inelastic. Okay, demand is inelastic. So so what we're saying is that if we have calculated on price elasticity of demand, and then we found that the value is greater than 1, then this means that demand is elastic, right? And then if you have calculated and then you found that the answer is exactly equal to 1, then this means that the demand is unitary elastic. Okay, and then if the value is lying between 0 and 1, let's say 0 point something, then this means that demand is inelastic. So for commodities who are with inelastic demand, for this one you can play with the price. It's okay. You can increase the price because you know that even after increasing the price, consumers have got no choice but to buy but to buy the commodity. And in most cases, you're going to find that these commodities whose demand is inelastic, most of them are controlled by the government. For instance, the case of Zesco. With Zesco, demand is inelastic because Zesco has got no substitutes for now. Okay, so no wonder Zesco can just wake up and increase the rate, because they understand that consumers have got no choice. Even if they cry, they will still end up buying Zesco units. All right. So that's the first type of elasticity. So which is on price elasticity. Right? How is that?
Oh, it's okay.
Okay, that's good. The second type is cross price elasticity. Okay, so that's the second type, cross price elasticity of demand. So this one measures the response. So it measures the response or the change in quantity demanded of one good, as a result of a change in the price of a different good. So we're going to say in the price of a related good. Yeah. So for cross price elasticity, just as the name itself, cross, which means that we're dealing with two different commodities. So it's a case of Coca-Cola and Fanta. So we want to understand how an increase in the price of Coca-Cola will affect the demand for Fanta. Right? So with this one, the formula is so elasticity between good X and good Y is equal to percentage change in quantity demanded, let's say of good X, as a result of a percentage change in the price of good Y. So you see, we are dealing with two goods, good X and good Y. So since it's cross price elasticity, we want to understand how a percentage change in the price of good Y is going to affect the demand for good X. So good X and good Y. Right? So this basically involves two types of commodities. It's either the goods we're dealing with are complements, or they are substitutes. All right. So if they are complements, we know that the complements are goods that that are consumed together. Maybe the case of tea and tea and sugar, or So for those you cannot have more of one and less of the other, unless otherwise. Yeah, but under normal circumstances, these goods must be consumed together. So those are complements. And you find that for complements, they'll always have a negative elasticity. Okay, so for complements, maybe we can write this point. So for complements, comma, on, sorry, cross, not on, cross price elasticity is always negative. Okay, and then for substitutes, it's the opposite actually. For substitutes, comma, cross price elasticity is always positive. All right, so why are we making these conclusions? Well, we know that for substitutes, these goods must be consumed together. So it's a case of, let's say, good X and good Y. So assuming that these two goods are complements, you cannot have more of X and less of Y. Neither can you have more of Y and less of X. So if there is an increase in the price of X, we know that according to the law of demand, an increase in the price is going to reduce the quantity that is demanded. So if there's an increase in the price of X, the quantity of good X will fall. But since these goods are complements, it also means that even the quantity of Y should also fall. So it's a case where the price of Y, let's say, has gone up, the quantity of X on top, so quantity of X will have to go down. So you see, in the denominator there we've got positive, there's an increase, but in the numerator we're going to have a negative, and this is going to give us a negative answer. So therefore, for complements, cross price elasticity is always negative. Okay, but for for substitutes, it's actually the opposite, because with substitutes, it's a case where if one commodity is not there, you can easily go for the other one. Okay, so for substitutes, cross price elasticity is always positive. Why is that the case? Well, we know that if I've got two goods, good X and Y, and these goods are substitutes, if there's an increase, let's say, in the price of Y, I'll just do away with Y, and go to X. Okay, so it's a case where the price of Y is going up. Well, quantity of the opposite good also, I will demand more of this good. So it's a case where the denominator is positive, the numerator is also positive. So this means that our answer will be positive. Okay, how is that?
So okay.
Okay, that's good. All right, yeah, and then the third case of elasticity is the income elasticity. So the third case is that of income elasticity. Yeah, so this one just measures the response of demand to changes in income. Okay, and the formula is so income elasticity is equal to percentage change in quantity demanded of good X due to percentage change in income. So income is represented by M. Okay, yeah, so that's the formula there for income elasticity. A few things to take note here under income elasticity. One is that for normal goods, so normal goods have a positive income elasticity. So normal goods have a positive income elasticity, and this value lies between 0 and 1. In short, if we have calculated the value, income elasticity, and then our answer is lying between 0 and 1, that is the income elasticity. So the answer is lying between 0 and 1. Then this means that the good we're dealing with is just a normal good. Okay, so a normal good is a good where an increase in income leads to an increase in demand. Okay, and then the opposite of a normal good is an inferior good. So inferior goods have negative. Okay, so these ones have negative income elasticity. So by definition, so if our EP is less than 0, okay, then it means that we're dealing with an inferior good. So an inferior good is just a good whose demand only increases as income is reducing. So you only remember about an inferior good as you become poor. Okay, so as your income is increasing, you do away with this good because it's inferior. So you only go back to this commodity as your income is reducing. So inferior goods have a negative income elasticity, meaning that the value is less than 0. Okay. Okay, how is that?
So far we are okay.
Alright, that's good. That's good. Okay, yeah, so now with this information, can we attempt the question at hand? So we needed this information before attempting this question 6. So now we are saying that suppose the demand function for a product is given by, so we have that as the demand function for a given product. Okay, yeah, so on the other side, so we are saying that demand for good X, quantity demanded for good X is equal to, so we have 3 minus 1 over 2 price of good X minus 2.5 price of good Y plus M, and then plus 2A. Okay, where PX is the commodity price, PY is the price of a related commodity, M is per capita disposable income, and A is advertising expenditure. Okay, and then we have also been told that PX is 10, the price of Y is 4, income is 20,000, advertising expenditure is 250. Then part 1. Okay, part 1 is saying determine the on price elasticity of demand and state whether demand is elastic, inelastic, or unitary elastic. Right, so we know that on price elasticity of demand, so EP is equal to, so this will be the change in quantity demanded of good X as a result of the change in the price of good X. Okay, so now we need to get the actual value. So what we're going to do is we are going to go back to our function. So quantity demanded is equal to 3 minus half px less 2.5 py, plus m plus 2a. So we are saying that we want to get on price elasticity of demand for good x. So what we're going to do is we are going to go back to our function, this function, and check where px is, because we want to understand the impact of a change in the price of good x, right? So in this function, px is this whole term here. So px is featuring there. So it's minus half px. So this px means the price of good x, right? So now we are going to differentiate this function with respect to px. Okay, so what we're going to do is, so ep is equal to where px is, like the term containing px is negative 1 over 2 px. So now it is this term that we're going to do, that we're going to differentiate. In short, we're going to use the concept of partial derivatives. Okay, partial derivatives involves differentiating a given function with respect to that particular variable under consideration while keeping everything else constant. So in this case, we are only going to pay attention to px and assume that everything else was not there. Okay, so price of y is not going to affect our analysis, income is not going to affect our analysis, advertising expenditure is also not going to affect our analysis. Why? Because our focus right now is on the impact of a change in the price of good x on the quantity demanded of good x, right? So we are going to differentiate minus half px with respect to px. So remember the laws of differentiation. We said that if I've got a function y is equal to ax to the power n, differentiating this, that is getting the dy dx, involves this. So we are going to get the power and drop it, so n, and you're going to multiply this by a. We're also going to multiply it by x, and then from the power of x we're going to remove a 1, right? So we're going to apply the same concept even here. Okay, we're going to apply the same concept even here. So our function is minus half px. So we know that this px, the whole px, this px is raised to a power. So there's a power there 1, even if it's not shown, but there is a power there 1. So we know that when differentiating, that power, the 1, should drop. So this will be 1 multiplied by negative half. We are multiplying this by px. And then from the power of px, we're going to remove a 1. Okay, so this will be 1 times negative half is going to give us negative half. We are multiplying this by px, but now this px is raised to the power 1 minus 1, and 1 minus 1 is a 0. Now in mathematics, anything raised to the power 0 is equal to 1, meaning that this px to the power 0 is equal to 1. So therefore, this is more like you're saying negative half times 1, which is the negative half. So therefore, on price elasticity of demand in this case is just the minus half. Okay. Yeah, so on price elasticity of demand in this case is just minus half. Okay, so how is that, the calculation part?
It's okay.
Okay, that's good. That's good. Yeah, so since we found our answer for elasticity, and then this answer is negative. Okay, remember what we've said somewhere there. We've said that if our EP is less than 0, then it means that demand is actually inelastic. Okay, in short, the other way around is to do this. Let me share with you a shortcut method. When you found your answer, just go on the number line. Just go on the number line. We know that there's a 0 here, and then here there's minus 1. Okay, So since this answer is lying between -1 and 0, because the negative half is more like negative 0.5. Okay, so we know that negative 0.5 should be somewhere here. So since this value is lying between -1 and 0, the conclusion will be that demand is actually inelastic. But if the answer was exactly -1, our conclusion would have changed. Would have been saying that demand is unitary elastic. So the other way around is you just go on the number line and check. So one more thing, I think I forgot to mention this. On price elasticity of demand will always be negative. Okay, so now the key is knowing the magnitude of this negativity. If, as it is in this case, the answer is negative and this answer is lying between 0 and -1, the conclusion will be that demand is actually inelastic. And if the answer is exactly -1, then the conclusion will be that demand is unitary elastic. And let's say that the answer is more negative than -1. Let's say it's -1 point something. Okay, then the conclusion will be that demand is actually elastic. Okay, so that is the key. So just look at the degree of negativity. Is this negative answer between 0 and -1? If it's between 0 and -1, then demand is inelastic. If the answer is exactly equal to -1, okay, then it means that demand is unitary elastic. And if the answer is greater, is actually more negative than -1, let's say it's -1 point something, -2, -3, -4, then demand is elastic. All right, how is that?
Okay.
All right, so yeah, in this case the conclusion will be that since our value is lying between 0 and -1, then demand is inelastic. Okay, so demand is therefore inelastic. So that is part 1. All right, then part 2, determine the cross price elasticity of demand between X and Y and state whether the two goods are substitutes or complements. All right, so part 2, we want to get cross price elasticity. Okay, so we want to get cross price elasticity, which we know that this is just going to be equal to, so elasticity between X and Y is just going to equal the change in quantity demanded. Okay, so the quantity demanded of good X as a result of a change in the price of Y. So remember that our demand function is this one here. So we want to understand how a change in the price of Y will affect demand for X. Okay, so how can we do that? Well, it's by as usual using partial derivatives. So we are going to go to our equation and check where Py is. So Py is there, and that is minus 2.5 Py. Okay, so we know that the term where Py is minus 2.5 Py. So we'll have to differentiate this. We will have to find the change in X as a result of a change in the price of good Y. And we know that this Py is raised to some power, and that power is 1. So we want to differentiate this. So we know that that 1 will have to drop. We multiply it by minus 2.5. We multiply this by Py. And then from the power of Py, we should remove a 1. So this will be minus 2.5 multiplied by Py. But now our Py is raised to the power 0. And we know that anything raised to the power 0 is exactly equal to 1. So we know that our answer will just be minus 2.5. So therefore, our cross price elasticity between X and Y is negative 2.5. Now remember that with cross price elasticity, we are trying to understand in this case, the impact of a change in the price of Y on quantity demanded of X. Okay, so if there's an increase in the price of Y, how is this going to affect the demand for X? Right, so in this case we are saying that an increase in the price of Y is actually going to reduce the demand for X, because this is what we are seeing. The fact that our answer is negative is telling us that these two goods are complements. Okay, so since since the value is negative, okay, this means that the two goods are complements. Okay, so the two goods are complements. Why? It's because an increase in the price of Y will actually have a negative impact on demand for X. So this then means that the two goods are complements. So you increase the price of Y, the demand, we know that the demand of Y itself will drop. But since X and Y are complements, they move together. The fact that the demand for Y has dropped translates to the fact that even demand for X should also drop. So yeah, so it means that the two goods they're complementing each other. So the fact that the value is negative means that the two goods are complements. All right, how is that?
It's okay.
Okay, that's good. Then part 3, determine the income elasticity of demand and state whether good X is a normal good or an inferior good. All right, so this time around we'll pay attention to that term containing M, because we know that M is our income. All right, so we go back to our function there and check where M is, and M is right there. It's positive, so it's plus M. So we'll have to differentiate that. Okay, so part 3, we want to get income elasticity. We know that income elasticity is equal to change in quantity demanded of X as a result of a change in income. And we know that the term we are differentiating is just this M. We want to differentiate that M. Okay, so yeah, we know that this M is raised to power 1. Okay, so this M is raised to power 1. So therefore elasticity of income is equal to, so the M is raised to power 1. We know that the 1 will drop. We're going to multiply by M, and then from the power of M we're going to remove a 1. Right, so this will be 1 multiplied by M, but this M will now be raised to power 0. Anything raised to power 0 is 1. So this is more like we are saying 1 times 1, which is a 1. So therefore income elasticity is exactly equal to 1. Okay, so since income elasticity is exactly equal to 1, this then means that so since income elasticity is equal to 1, this means that good X is a normal good. So remember, for normal goods, the value will range from 0 to exactly 1. Okay, so that is for a normal good. And for an inferior good, it will be negative. Okay, because we know that a normal good is just a good whose demand is going to increase with an increase in income. So as your income is increasing, you are going to demand more and more and more of this particular commodity, right? Yeah, so since the value in this case is equal to 1, we are going to conclude that X is a normal good. Okay, so X is a normal good. How is that?
Okay.
Okay. Yeah, then part 4, can we determine the own advertising elasticity of demand? Right, so can we determine the own advertising elasticity of demand? Alright, yeah, so on advertising elasticity of demand. So part 4 on advertising elasticity. So in this case, we'll be getting yeah, so I want to get elasticity with respect to A, which is the change in quantity demanded of good X as a result of a change in A. Okay, and now as usual, we'll have to go back to our function and check where is A. So A is there, positive 2A. So we'll have to differentiate this 2A with respect to A. Right? So we know that the A is raised to power 1. So that's going to be 1 by 2 multiplied by A. From the power of A, we're going to remove a 1. Okay? So this will be 2 multiplied by A, but now the A is raised to power 0, and anything raised to power 0 is just a 1. So this will just be 2. So this means that elasticity of advertising is giving us a 2. Okay, so this practically means that the more you advertise, the more people will know about your product and demand will increase. Why? Because the answer there is positive. If the answer was negative, then the conclusion would have been that the more you advertise, actually you find that demand is falling. Okay, so maybe it could be that you're using wrong methods of advertising, yeah, for you to have such a case. But in this case, since the answer is positive, then the recommendation will be, can we continue advertising? Because the more we advertise, the more our demand is increasing. So yeah, people increase the demand due to our intensive adverts. Okay, how is that, madam?
Okay.
Okay, that's good. So you can move to part 5. Part 5 is saying, can we derive the equation for the demand curve for the commodity and quantity at the price of 20? So now this one is saying that given that everything else is as it is, okay, only px has changed, because initially px was 10, there initially. So the price of x was 10 initially, but now our p2 is 20. Okay, everything else is the same. So py is still 4, income is still 20,000, advertising expenditure is still 250. So the question is saying, can we derive an equation for the demand curve? Okay, can we derive an equation for the demand curve? I'm sure practically this question is asking us to say, given that px is 10, so given that the price is now 20, and then py is still as it was, 4, and then m is 20,000, advertising expenditure is 250, how many units of x can be bought at such conditions? Okay, so we know that qx has been given to be equal to 3 minus half px minus 2.5 py plus m plus 2a. Okay, so we are saying that qx is just going to be equal 3 minus half. The price of x is no longer 10, it's 20 now, so we have a 20 there. Okay, we have a 20 there, and then minus 2.5. The price of y is now 4, right? And then plus the income is still the same, 20,000, plus 2 multiplied by advertising expenditure, 250. So now we just have to simplify this. So this will be 3 minus half of 20 is 10. Okay, and then minus 2.5 times 4 is also a 10, plus 20,000, plus 2 times 250 is a 500. So now how many units can we buy? So this would be 3 minus that, plus 20,000, plus that. Hoping that my punching is correct, I'm getting 20,483. So this means that given these conditions, okay, given that the price of x is no longer 10 but 20, we can demand 20,483 units, given that everything else is as it was and only the price of x has changed from 10 to 20. Okay, so we'll be able to demand for 20,483 units of good x. How is that?
Okay.
Okay, that's fine. So I'm asking if we can end now. Is it okay?
Okay.
Okay. So I'll send